In this video, I'm going to analyze a position time graph, and the way I'm going to do it is I'm going to answer these three questions for each of these segments that's drawn in. The first thing you do when you have a motion graph is you write down what the slope equals. That's step one. Slope is always change in y quantity divided by change in the x quantity. Our y quantity here is position, and the x is time. The change in position over change in time is something we know, that's equal to velocity. So step one is finished. Let's start with segment A. Is the slope velocity always positive, negative, or zero during A? A goes up, so we know the slope is positive for this section A. So instead of writing slope is positive, I'm going to write velocity is positive during A. Whoops, hang on. Velocity is positive. Next, is the velocity, the slope, increasing, decreasing, or staying the same? A is a straight line. Straight lines have constant slope. That means during A, the slope is constant, but I'm going to write the velocity is constant. The next thing, is the acceleration positive, negative, or zero? Acceleration measures how much the slope changes and how quickly. In fact, the equation for acceleration says so. Acceleration is given as defined as change in velocity over time, or we may write delta t depending on what class we're in. Oops. So change in velocity over time, if the velocity is constant, there is no change. The change is zero, and hence the acceleration is zero. So for segment A, the acceleration is zero because the line is straight. It's not curvy. Let's move on now to part B. And let's see what I can delete. Oops. All right, there we go. Oh no. There we go. Good. Slope, we remember, is velocity. Okay then. For segment B, we look and ask, is the slope, the velocity, always positive, negative, or zero? Well, because the line is going down, curving down, we know that all of the slopes will be negative. We can actually draw in tangent lines to confirm this. Right here, the tangent line is like so. Over here, the tangent line is like so. And over here, the tangent line is like so. All of these tangent lines are sloping down, so the slope is negative for all of B. But instead of writing slope is negative, I write V, velocity, is negative. The next question says, is the slope or velocity increasing, decreasing, or staying the same? I look at these tangent lines and I see they're getting less and less negative. This one is really steep, so it's like negative 20. This one is less steep, so negative 15 maybe. This is less steep still, negative 10. Whenever the slopes get less negative, we have an increase in slope. So right here, the slope is increasing, except instead of writing slope, we're going to write velocity is increasing. Is the acceleration during B positive, negative, or zero? Well, if the velocity increases, delta V, if the velocity increases, we are adding velocity each time. That means we have a positive change and we have positive acceleration. So we would write A is positive. Now let's do segment C. Get rid of this. Let's see. Whoops. Get rid of those. Don't need the tangent lines anymore. And get rid of that. For segment C, we look and ask, is the slope, the velocity, always positive, negative, or zero? C is a straight line sloping down. Because it's a downward line, the velocity, the slope, is always negative. For C, we see that it's a straight line, it has constant slope, thus the velocity is constant. Whenever the velocity is constant, that means it doesn't change, and that means we have zero acceleration. The acceleration measures how much it changes, that velocity, and this velocity doesn't change, so there's no acceleration at all. That was easy. Let's move on to the next one. Let's see. Here, get rid of that and that. For segment D, is the slope velocity always positive, negative, or zero? D is a horizontal straight line. Horizontal lines have a slope of 0, but instead of writing slope equals 0, whoops, instead of putting slope equals 0 in my answer, I'm going to put, not slope, but velocity equals 0. Is the slope, the velocity, increasing, decreasing, or staying the same? D is a straight line, so it has a constant slope. That means the velocity is constant. It remains, that velocity remains at 0 for all of D. It's constant. Is the acceleration positive, negative, or 0? Well, if we're not adding speed, and if we're not decreasing the speed, subtracting away some velocity, then we have no acceleration. So let me say that again. If we're not changing the velocity, if it's constant, the acceleration is zip, nada, nil, 0. All right, on to the last example. Section E, the last segment. In section E, we ask, is the slope velocity always positive, negative, or 0? This line is going up on the whole, so we already know it will be positive slopes the whole way. But let's confirm that with some tangent lines. Right here, the tangent is like this. Right here, the tangent's like that. And over here, the tangent's like that. All of these tangents have upward sloping lines. They all have positive slope. So the slope is always positive, but instead of saying slope is always positive, I'm going to say V is always positive. Is the slope increasing, decreasing, or staying the same? These tangent lines are getting less and less positive, less and less steep in the positive direction. So as they decrease, as they get less steep, they decrease. The slope is decreasing, but instead of writing slope is decreasing, I'm going to say V, the velocity, is decreasing. The last part is the acceleration positive, negative, or 0. Clearly, we don't have 0 acceleration because we do have a change occurring in the velocity. Specifically, the velocity is decreasing. If we have a decreasing velocity, that means a negative change in the velocity. So the numerator would be negative, making the acceleration negative. Acceleration is negative. And that completes our analysis for this example.